Right, so let's have a look at question 3. We have the following function. We need to show that this function f is discontinuous at x equals 0 and discuss this discontinuity. Now, first of all, when we're checking continuity, we need to check the limit from the left and the limit from the right. So first I'm going to have a look at the limit as x tends towards 0 from the left of my function. Now remember, this is the function that we're dealing with. If x is less than 0, my function is x. So that is the function that I'm dealing with here. Okay, so the limit from the left, we make x to be 0 because we can sub directly for this limit and we get 0. Now let's look at the limit as x tends towards 0 from the right. Now if you have a look, when x is greater than or equal to 0, have a look at the function we have. That is our function. So again, we can sub our x to be 0 into the function negative x squared minus 1, and we get negative 1. So you see that we get two different limits. So we know that therefore the limit as x tends towards 0 from the left of our function is not equal to the limit as x tends towards 0 from the right of our function. Therefore, we have a jump discontinuity. Mark allocations for that question. You get one accuracy mark here, an accuracy mark for stating that, and another accuracy mark for getting the correct type of discontinuity. Now the next question says, determine whether f is differentiable at x is equal to 1. Now that's different to continuous, but you first need to check whether the function is continuous at that point. If it's not continuous, then obviously it's going to be non-differentiable straight away. But we need to check. So let's first have a look at the limit as x tends towards 1 from the left. Now let's go back up and have a look at what function that will be. Now when x is between 0 and 1, we're dealing with that function again. So that is the one that we're dealing with when x tends towards 1 from the left. Okay, so we're dealing with the function negative x squared minus 1. In this limit, we can sub x to be 1, in which case we're going to land up with negative 2. Okay, let's have a look at the limit as x tends towards 1 from the right. Let's go back up to check our function. We know when x is greater than 1, we're dealing with that function, negative 2. Y equals negative 2. So, let's have a look. We can't sub x to be 1, so that limit is immediately negative 2. Okay, so therefore we know that our function is continuous. That's the first step, because the limit from the left is equal to the limit from the right. Therefore we know it is continuous. Now that we know it's continuous, we need to do the test for differentiability. And that's the limit of the derivative from the left and the right. So I'm going to first have a look at the limit of the derivative. So I've got the limit towards 1 from the left of the derivative. Now we know, let's actually write that derivative out. The derivative of negative x squared minus 1 is negative 2x. Replace x with 1, and we get negative 2. Now the limit, as x tends towards 1 from the right of the derivative, what's the derivative of that function? We can just look up. The derivative of that function, well, the function is negative 2, so the derivative is 0, so the limit is immediately 0. From that we can see that the limit from the left and the right is not equal. And you probably should write that. We didn't assign a mark for it, but I don't leave myself enough space, so I'm just going to say therefore not differentiable. Right, so let's just have a look at the mark allocations there. Firstly, I need to have a method of using limits and an accuracy mark for that whole step. There we go. Then I have a method mark here for using derivatives, an accuracy mark for doing it right, and you just got a mark for your conclusion based on your working. Now the last question asks you to sketch this function. Now we know, let's just scroll up again, we know that before 0, we've got the function y equals x, which is a straight line. And most of you got that part right. So let's pop that straight line in. Doesn't have to be 100% accurate. We're going to pop it in there. That's the line y equals x. Then we saw that between 0 and 1, we've got negative x squared minus 1, which is a parabola. It's a sad face parabola. It's one of the maximum, and it's shifted down 1. Again, it doesn't have to be 100% accurate. You can just sketch that in. And that's between 0 and 1, so I've got to have a cutoff. So I'm going to draw it. Actually, let's change our color there. Take that out. Do it in black. Okay, so I draw in my parabola. Oh dear. See if it goes black this time. There we go. So there's that part of the parabola. Up until x is 1. Thereafter, but when x is greater than 1, my function is negative 2. It's y equals negative 2, which is a horizontal straight line. So let's pop our straight line in again from that point onwards. You just need to make sure that you get the right dots in the right place. So let's go check again. The first function is when x is less than 0. So it must be an open dot because it's not when it's equal to 0. So there's my open dot. The next one is when x is greater than or equal to 0, less than equal to 1. So I can have a closed dot there, and I can have a closed dot there. Just make sure that you put in that coordinate. X is 1, y is negative 2. So an x and y. Your mark allocations here, you get an accuracy mark for your straight line, an accuracy mark for your parabola, and an accuracy mark for your horizontal straight line.